100,000 tons. Pause and let that number actually sink into your brain for a second.
That is the crushing weight of a fully loaded mega-container ship, roughly equivalent to stacking 10 Eiffel Towers on top of each other. Now, to cross the Americas, this steel beast has to do something that sounds physically impossible: climb a mountain. It needs to get lifted 26 meters above sea level, cruise across a continental divide, and then go back down on the other side.
Here is the kicker. There are no giant cranes strong enough to lift it. And surprisingly, there are no massive electric pumps either.
So how do you lift an island of steel into the sky without burning millions of kilowatts of electricity? You use the one force that never sleeps. Welcome to the Panama Canal, a 100-year-old machine that runs entirely on a physics loophole called the gravity elevator. To understand this magic trick, you have to look at the heart of the system, Lake Gatun. This isn't just a lake, it's a massive artificial battery made of water sitting 26 meters above the ocean.
It holds billions of gallons of fresh rainwater collected from the tropical rainforest, just waiting to be used.
The entire canal works on a principle you probably learned in middle school and then immediately forgot: communicating vessels. The rule is simple. Water always wants to be level. If you connect two tanks, the water flows until they match. The canal is basically a giant staircase made of 3 concrete chambers or locks connected by underground tunnels. Let's walk a ship through this. Step 1, the ship enters the first lock chamber at sea level. Behind it, a set of massive steel gates, each weighing 700 tons, swing shut to seal the chamber. Now, the ship is trapped in a concrete box. But here is where the engineering genius kicks in. Underneath the floor, there are culverts, huge tunnels that connect this chamber to the next one, which is higher up. Operators simply open a valve. No motors, no pumps. They just turn a wheel. Gravity yanks the water from the higher chamber down into the lower one where the ship is waiting. The water rushes in through hundreds of holes in the floor, filling the chamber like a giant bathtub. As the water level rises, the 100,000-ton ship floats up with it. Archimedes is doing all the heavy lifting here. In about 10 minutes, the water levels equalize. The ship has just been lifted 9 meters for free. The forward gates open, and the ship glides into the second chamber. The process repeats. Water flows from the top lake again, lifting the ship another 9 meters. Silence, except for the rushing water. Finally, the third step. The gates open to Lake Gatun itself. The ship floats out, now 26 meters above the ocean. It crosses the lake and then goes down the other side using the exact same process, but in reverse. Instead of filling, they drain the water into the lower chamber or out to the sea, lowering the ship step by step. This system is so robust, it has been running since 1914, but it's not without its flaws. Let's put you in the captain's chair of a Neo-Panamax ship, the new class of giants built just for this canal. These things are 366 meters long. The lock chamber is barely wider than the ship itself. You have a clearance of only 1.5 meters on each side. That's less than the length of a bed. One wrong move, one gust of wind, and you scrape the concrete walls. So you turn off your engines. Enter the mules. These are electric locomotives running on tracks along the lock walls. They attach steel cables to the ship's bow and stern, keeping it perfectly centered in the chamber. As the water rises, the mules drive along the tracks, pulling the ship forward with surgical precision. It looks effortless, but there's a massive hidden cost to every single transit. Every time a ship goes through, 200 million liters of fresh water gets flushed out into the salty ocean. That is fresh drinking water for Panama City, gone forever in about 45 minutes.
When the dry season hits and rain stops falling, Lake Gatun shrinks. The battery runs low.
Authorities have to restrict ship weights or close lanes entirely. Global trade literally gets stuck in traffic.
So engineers had to upgrade this 100-year-old system to stop bleeding water. The solution? Recycling. They built the new Cocoli and Agua Clara locks with a secret weapon: water-saving basins. Instead of dumping water into the ocean, they drain it into these adjacent pools. When the next ship comes up, they pump that saved water back into the lock chamber. This system recycles 60% of the water used per transit. It's a game changer for the drought seasons. They also ditched the old swinging gates for rolling gates. These are hollow steel boxes. They can actually float. By pumping air in or out, they adjust their buoyancy to roll open smoothly.
This means less friction, less maintenance, and they can be floated out for repairs without cranes.
The Panama Canal is proof that you don't always need brute force to move mountains. Sometimes the smartest engineering is just understanding the rules of nature and letting them do the work. We didn't conquer gravity here. We partnered with it to lift 100,000 tons into the sky. If you want to see another physics miracle, check out the video on the right about how lightning actually works.
And hit that subscribe button if you want to understand the world without the boring textbooks.